All of the shapes here are basically cubes. They're made with 8 corners that are triangles and 6 faces that are basically squares. By square I just mean a loop with some multiple of 4 magnets in it. The triangles go in the corners and the squares become the faces. Although this shape here is possibly so flimsy that there's an actual art to balancing it without it falling over, it's possibly a good one to demonstrate because it's very clear, the triangles on the corners. There's more over here. And the squares, which are these loops there, they have, in this case, 24. And the little triangles have got 6. You can see that this one's fairly flimsy. If I put it down crooked, it won't balance, so I usually store it by clipping the sides together. It looks, if you clip it neatly, it looks okay. Put that out the way. Smallest one, it's still got a square which has only got 4 in it, and 8 triangles. It's so solid you can roll it around, it's quite strong. This one here is so flimsy that I needed to support the base in order to make it stand up, but nevertheless you can make it stand up. And now you see several examples that are quite sturdy, intermediate sizes, like bigger triangles, small square, medium sizes. This one's kind of nice, it's got lots of space in it. So the basic procedure to make triangles is just grab and push, make like that. And you assemble them. You can just assemble them one at a time. I've just taken one apart to make that. Put them together like this, and then put them in. Now you put them in that way, not that way, so that all the corners or the vertices of the solid have one orientation, so clockwise, and all the faces are the opposite. You call it anti-clockwise. And just keep clipping them on. It's very quick. It doesn't take many magnets because it's mostly space. You can also make it slightly differently. In this case, instead of little triangles, I've used a loop, and that means that I don't have to have it the opposite orientation to here. It can be clockwise and clockwise. They're not quite as strong. It's also possible to build another similar shape on top of the first shape, and to keep doing that ad infinitum until it collapses under its own weight. And they're not stacked, the bottom of this one is actually the same square as the top of this one. I'll show you what I mean. So here's the one I built earlier. You use instead of 9 for your triangle, make a triangle with 8 but with one corner missing, and just on top of the old triangle build it like that. So you got 8, and then you build up. Hang on, what have I done? I've attached it. And then you'll do that on each corner, and then put a green circle here and build it again. And that's, it actually gets a bit stronger, and you get these good lines of sight through it. And what you see here is a generalisation of the principle based on a dodecahedron, which is 12 pentagons arranged in a ball. And just as a cube has 8 triangles, 4 on each square, this has got one for each corner of the pentagon. There's lots of them. And then the faces are some multiple of 5. So in this case I've used 15, I could have used 10 or 5, and it wouldn't have been stable to use anymore, 20 or something. But it's stable. It will stand up as shown, but it's sort of hard to make it stand up without collapsing. You've got to put it down very carefully. You can always blame the first person who touches it after that. The general principle is, if there are 3 faces coming together, 1, 2, 3, you have to, and the corner has 3 faces coming to it, you need a triangle. If, as in an octahedron, you had 4 faces, you would use a little square. And that corner loop, or the corner triangle, has to be the opposite polarity to the faces, so that it'll join in that manner.